map of our world is about to change. I'm talking about the continent of Africa splitting into two.
The ground beneath East Africa is opening in a way that feels almost unreal, and scientists are watching a new ocean begin to form in real time. Vast cracks stretch across the land, revealing glowing rock deep below the surface, and satellite images show a continent slowly pulling apart. This process should take millions of years, yet it is happening during our lifetime, raising questions that no model can fully answer. If the Earth is changing this fast, then what will it mean for our climate, our coastlines, and our future? So what exactly started this extraordinary shift? The week of the Dabahu eruption stands as one of the clearest warnings that the Earth can change faster than we expect, and it began with a chain of earthquakes that shook the Afar region without pause. Researchers recorded more than 130 quakes in only 7 days, and each tremor carried the same message that something deep below was moving with unusual force. Villagers described the ground as if it were breathing, rising and falling through the night, while scientists noticed that the quakes were lining up along the same hidden fracture. This pattern showed that the crust was stretching as pressure rose from the mantle, and it pushed the region toward a dramatic breaking point. The eruption on September 26th revealed the true scale of this event, and magma burst through the surface with a strength that created a scar across the landscape. A fissure 37 miles long opened within hours, and parts of it were wide enough to swallow roads, farms, and entire sections of volcanic rock. People who lived nearby ran as ash filled the air, and more than 6,000 were forced to leave their homes while the land kept splitting beneath their feet. For many families, livestock disappeared into the cracks or died from the toxic heat, and this sudden loss destroyed the only source of income they had. The chaos turned quiet villages into temporary camps, and help arrived slowly because the ground continued to shift as rescue teams approached. Scientists called this eruption a rare window into rifting because it unfolded at a pace that humans could see, and they captured satellite images showing the crust pulling apart in real time. These images showed blocks of land moving several meters over a few days, and this motion usually takes thousands of years to measure. The Afar region became a natural laboratory where magma rose through narrow channels, creating new rock as it cooled while widening the fracture with every pulse. Ground teams placed sensors across the valley and found that some areas had dropped by several feet, while others had risen slightly as molten rock pushed upward. This uneven motion proved that the plates beneath East Africa were unlocking from each other, and the eruption acted like a spark that accelerated the entire process. The Dabahu event also exposed how fragile communities become when the Earth shifts, and it showed that survival depends on understanding the signals beneath the surface. Farmers had to find new grazing areas, and many wells dried up because the rocks that held groundwater had cracked apart. These changes forced people to move towards safer ground, and they had to rebuild while still hearing small tremors every night. Even after the eruption ended, the region remained unstable because magma continued to rise through the deep fractures, and scientists warned that the ground would keep changing for years. For many experts, the most important lesson from Dabahu was that Africa's rifting process is no longer a distant theory, but a living reality, and the eruption marked the first chapter of a much larger transformation. If 1 week of seismic activity could reshape an entire region, what might happen as the rift continues to grow? The East African Rift stretches across the continent like a deep wound, and it marks the line where Africa is slowly tearing into two separate landmasses. This system begins in the Afar Depression of Ethiopia and continues through Kenya and Tanzania before reaching Mozambique, and it forms one of the most dramatic geological features on Earth. Scientists describe it as a living boundary because the crust here is not stable but constantly shifting, rise